on that device. So f of x is 4 over 3 x cubed minus 2x squared plus x. Show everything including x factorized only, yeah. So this problem, right?
Yes.
Hirsch? Okay. So did you have any difficulties? Do you want me to address a particular situation, or you just want me to show the problem from the beginning till the end, or what do you have in mind?
So I didn't have any problems with finding the derivatives, but it was the part where we graph it. Like,
okay, in that case, let's do the whole thing, because this is very important. This will be a major topic for the final. Okay, so let's do that. So I start my table. I'm in class till 8:30. Bye. Sorry about that. I look because it may be a student. Otherwise, I will not. I will keep it. When I'm in class in front of my students, all my devices are off. So my apologies. Okay, so obviously this is a polynomial. It's defined everywhere. I will have to plug in 0 in it to find the y-intercept. And I am looking for the calculator I trust to give me the solutions quickly, because you can do that in different ways. So I just don't want to spend time with finding x-intercepts. So the first is 4/3, -2, 1, and 0, and I want to get the x-intercepts. So 2 of them are imaginary, so there is only 1. Okay. Good. So next step, I have to find the limits. Just put my markers here to keep it on straight, but it's in the way. So limit as x approaches -infinity from 4/3 x cubed minus 2x squared plus x, the answer is -infinity. And the same for x approaches infinity, the answer will be infinity. At this point, I will determine the first derivative. I bring down 3, so that's 4x squared minus 4x and plus 1. And it turns out that this is nicely factorable. So when I set it equal to 0, I get x equals 1/2. And 1/2 is the only critical number. It happens that the derivative does not ever change sign. So I have to show that this function is always increasing. But first, I will plug in 1/2. I trust this calculator to do that. Okay. So 4 divided by 3, x to the third, and then minus 2x squared and plus x. And second in table at 1.5, and it says 0.2 roughly. Okay. So next I make sure that the two rows work well together. From -infinity to infinity, yes, that's okay. From 0 to 0.2, yes, that's okay. And to obviously, this is not a local max or local min because the function does not change sign. The derivative does not change sign. And finally, I'm looking at the second derivative, which is 8x minus 4. And when I set this equal to 0, I get x equals 1/2. Fine. Wonderful. So this is a linear function. It looks like this. So the sign is negative and then positive, which means it does not hold water, and it does hold water. It's not symmetric. I will write on the side, not symmetric. And I can write y, f of -x will never equal f of x, and it will not equal negative f of x either. And now, with the table alone, I will graph the function. I don't need anything else. Any questions so far before I graph it? Did you understand your mistake? If you have any, I don't know.
Quick question.
Yeah. Can you check again for the f is because when we got 1/2, I got 1/6 instead of.
So it's very possible. You mean this number here?
Yeah.
Okay. Yeah, let me check my function. 4/3 x cubed minus 2x squared plus x. Maybe it didn't take 0.5. Okay, let me check again. So it's 4/3 x cubed. Yes. Minus 2x squared plus x. See, that's why I don't trust this calculator, to tell you the truth. Did you enter it like this? If you didn't put parentheses around 4/3, then you got a different number. So you have parentheses 4/3 x cubed minus 2x squared plus x. I'll do it again. 0.5. The answer is 0.2. I can use a different calculator. So in y equals, I'll use this one. See what this one gives. X to the third, and then minus 2x squared, and then plus x. You should always stop me even if you see something, you may be right, I may be wrong. I don't mind going back and checking. It's always the case. Okay.
Hey, Professor.
Yes?
So, since we did 1/2, we know that 1/2 is one of the numbers that is like a critical number, right?
It is a
Is that the
critical.
one,
Yes.
or
Yes.
is that the only critical number, or is 0.2 the other critical number?
So the first derivative is 4x squared minus 4x plus 1, which factors into 2x minus 1 squared. If you want to say that this has two solutions, I agree, but they're both 1/2. Is that what you meant?
Yeah, that's kind of what I wanted to know. Thank you.
So is there something else that you wanted to say?
No, that's it. I just wanted to make sure that it was 1/2.
It's 2x minus 1 times 2x minus 1. You will only guess one solution. It's a double solution, but it's the same. Very good questions. Is this okay? Can I go back to the number then? Okay, so Nee, am I okay with this number? If I'm not, I'll go back.
I think
I couldn't hear you. Speak up.
hold on, I check my menu because when I press on my calculator, still 106, not over 1, not 0.2.
It does not give you 0.2? Or it does? I couldn't hear you.
I'm not.
But did you put parentheses around 4/3?
Yes, I did.
And did you multiply by x cubed?
Yeah, that's exactly what I wanted.
So did you go to second and table? Did you plug in 0.5?
Yes,
Did you get 0.2?
I get 1 over 2, and still 1.66. That means 1/6.
Yes, but it's the same. It's 0.2. I cannot plot 1/6. Can anyone confirm 0.2? Anyone?
Even when I do manually by hand, also 106. So
You say 1/6 or you say 1.6?
1/6. So means 0.
Okay, let me do it by hand to show you what it is. Okay, I got it. So let's do that by hand. So f of 1/2, which is 4/3 times 1/8. Is that okay?
Yeah.
Minus 2 times 1/4. Is that okay?
Yeah.
And plus 1/2.
Yeah.
Okay. So obviously this is 24. So the least common denominator will be, let me simplify it first. So I get 4 divided by 24. And, right? So this is negative 1/2 plus 1/2. I don't need anything. So 1/6. Okay. Okay. And 1 divided by 6 is 0.2.
Oh, you. Okay.
I cannot plot 1/6. I still have to approximate to see what it is.
Alright, sorry.
No problem, no problem. I'm glad we fixed that. Good. So then I'm going to start graphing this function. Zero, zero. And this is tiny. I'm going to take a big unit. So at 1/2 is 0.2. Okay. So then the function comes from negative infinity increasing to the origin. It goes to this point, continue to increase till 1/2 0.2, which becomes an inflection point, IP, and it changes concavity, and it does this. And that's final. And that's the graph of f of x equals 4/3 x cubed minus 2x squared plus x. Okay. Other questions here, Harsh? Is this okay? What was the problem again with this one?
No, I found out what I think I found out where I made a mistake.
That's
So
fine. That's fine. We all make mistakes. Good.
thank you for going over it.
That's perfect. Other questions for me? Anything else? Anything else?
Also,
Yes,
I have one more.
please.
To find the max and min, do you first find the first derivative, and then whatever you get for the first derivative, do you plug that back into the original equation? Or do you
So,
have to find?
okay. Did you watch the videos we did in class? I would highly recommend it. So, after I find the critical number, I must find this because this is the point that I have to plot.
No, I'm not talking about this problem.
Oh.
It's a different problem. It's
Oh.
for a different problem, that's why.
For any problem, after I find the critical number, I have to find the y value for that x.
Mm-hmm.
So for every number that I put in the table at the top in the x, I have to have a corresponding y value in the row for f of x. Otherwise, I will not be able to plot the point.
Okay.
So whatever, if you have here 10 numbers, you have to have 10 numbers here corresponding to each, because otherwise you will not be able to plot them. You are not plotting the first derivative. You are not plotting the second derivative. You are plotting x comma y, x comma y, x comma y, x comma y. And if you don't have the corresponding y value, you will not be able to plot the point.
Mm-hmm.
Is that what you meant? Did I misunderstand, or is that okay?
I got it now.
So the moment I get any number that I put up here, I have to find the corresponding y value. If it's coming from x and y intercepts, if it's coming from the first derivative, if it's coming from the second derivative, it doesn't matter. Whatever I put here has to have a corresponding in the f of x.
Okay.
Good. Sorry, I should have said that, but I thought it was clear, but it's my fault. I should have said it in class, why we need to do that. Sorry about that.
No, you're fine, but thank you though.
Sure, thank you. Other questions for me before we start 2.6? Anything else? You can stop me anytime. It doesn't matter. We can start and I can go back to any problem you have. Anything else? Other questions? Anyone? Okay, well, in this case, let's continue with 2.6. This is all about, it's a section also in applications. It's called marginals and differentials. I'm going to talk about differentials first, because it's easier to understand the marginals when we go through the differentials first. Now, do you remember that we used these notations, either y prime or f prime or dy over dx? Do we remember this? Anyone? Have we seen all these three notations?
Yes, I do. I remember it.
Good. That's all I wanted to hear. Okay, so let's take a look at the following function. So let's say this is a function f of x. This is a point P, and the coordinates are x. And here's a point Q. P and Q are very close together, but if I put them right here, I'm not going to be able to explain. So just imagine that we zoom in. But P and Q are close to each other. And this is x plus dx, or x plus delta x, where this is dx, which equals delta x. So take it as a minor error. So you could say the dx and delta x, that's not what they will be called, but or they are called. But just imagine that P and Q are close together. So dx and delta x are the same. This is like a minor error, and it's a small number, 1 or below. Okay. Now, can anyone give us the y coordinates for P and Q? Anyone? The y coordinate for P is f of x, and the y coordinate for Q can be f of x plus dx, also equal to f of x plus delta x. Okay. Now, looking back, I am going to, looking back at the graph, I'm going to draw a tangent to P. Here is the tangent. And I'm going to extend it. And this is the tangent at P. I'm going to form a right triangle. And I'm going to take it out of there so I can put it on the next page, so I can explain what this means. And I'll come back to write a few things there too. So here's Q. Here's P. And here is dx. Now, can anyone tell us what this is? This is what is called delta y. Delta y is the actual change in f of x for a change, or produced by a change in x, of delta x equals dx. What does delta y equal to? Well, delta y equals to f of x plus dx minus f of x. So f of x plus delta x minus f of x. And this is the exact change that is produced in the function triggered by a change in x. Coming back now to my graph. So this was delta y. At this point, I'm really interested in determining this. And discussing what that means. So on the actual graph, I'm talking about this distance. So see, this is a right triangle. In this triangle, I know that the slope of this line, the slope of the tangent at P, maybe this is not a good color. So the slope of the tangent at P is rise over run, and also because it's the slope of the tangent, it's f prime of x. I do have the run, dx. So the question is, what is this? Which is the run, the rise. So what do you think this will be called or labeled? Which is right here. And this is why I started with this. I have f prime, I have the x. This must be what it's called the differential of y. So this is indeed dy. On the actual graph, this is indeed dy. Notice that since P and Q are so close together, we can freely conclude that if this is small, the difference between these two is small. Yes, it doesn't appear to be small here because I zoomed in, but Q is very, very close to P. So obviously, when this is a small number, these two will be close to each other. So dy is the differential of f of x or of y, same thing. So what does it equal to? Cross multiply, and you get f prime of x dx. What does it represent? Dy is the difference in f of x for a small dx delta x calculated with the derivative. It isn't the exact difference, but the approximate difference. It is not the exact. The exact is delta y. Dy is not the exact, it's the approximate. Knowing now, so this is the exact, and this is the approximate. So at this point, I would write that delta y is approximately dy. I could never use the equal symbol. This is determined with the function values, and this is determined with a derivative. I will copy their formulas. So this is f of x plus dx minus f of x. It's approximately this, which is f prime of x dx. Finally, I will move this to the other side. And this is a very important result. Very important result because we can approximate anything we want. So now, if we are looking at any function, if dx is 1, and let's say x is 10, as an example, then f of 10 plus 1 will be approximately f of 10 plus f prime of 10 times 1. So this is an example for you, because we're going to use this in marginals.